Hello everyone. In this new tutorial video, I will demonstrate the new feature in the physical oversampling Python code, that is to directly derive emissions from satellite level 2 data. The details can be found in this newly published paper on GRL. And I will use the Tropomi L2 level 2 data in this demonstration, and only the level 2 data. Okay, so we start with creating a Jupyter notebook in the right Python environment, and starting with adding a few packages right here. So if you want to use the feature to derive emissions, make sure to download the newest Poppy code, which is maintained on GitHub. So, and this is the directory where I put the script. So I can run this. And everything is contained in this wrapper function. So it should be backward compatible, which means you can use it for the previous applications. But as you may see, there are quite a few inputs now can be specified to generate the emissions. Okay, so we start with specifying the instrument, which is Tropomi. The product is NO2. The grid size is recommended to use 0.02 or even smaller to resolve the level 2 pixels. And let's choose a smaller domain over the Northeast United States. So the size of the level 3 data is manageable. You can just leave the column unit to be none, which uses the default. And since we are going to use the level 2 files, then we will specify this to be false. So we are not going to use the pre-saved level 2G file. The subset function is okay to just leave it as default, since you have already specified Tropomi and NO2, but we can be explicit here. So this function should already be implemented in the source code. Okay, so it is here. And now let's go back. We have a subset keyword input. So if this is none, then it will just use the default inputs defined here. But to derive the emissions, we will need the wind fields. And by default, it's not included, so we will specify them. So the real useful inputs are those two data fields and data fields level 2G. So if those are none, it will use the one listed here. But those do not contain the wind fields. So let's specify that. And instead of leaving those as none, we will make a small modification. Okay, so those will be the default fields in the level 2 files that will be subset. But we want to add the wind fields that are already in the level 2 files. So we can see from here the README file of the official level 2 product of Tropomi L2. So those two fields are already there. And we can give them those two fields a shorter name. Let's call that level 2U and level 2V. Okay, and then we need to tell the wrapper function where the level 2 files are. One way is to just directly give a list of the path of the level 2 files, or like we have done previously, create a pattern. So in my system, the level 2 files are saved in this directory and with the standard file name. So we will specify that like this. And then let's use 6 cores. Okay, so let's just use for a quick demonstration. Let's just do that with 1 day, starting with September 1st of 2021. And after 1 day, you can leave those blank. And this gradient keyword argument has to be specified for the emission calculation. And this should be the dictionary input to a function called f underline prepare gradient, like this. So we need to at least specify the name of the wind in the zonal and meridional directions. Let's specify them here. So the X wind field, since we directly leverage the wind field that are already in the level 2 files, those may not be the most accurate one, but it should be the easiest one, as you will not need any external sources of meteorology. So you can see you gave those two the horizontal wind vectors an arbitrary name, and just make sure they are consistent over here. It has the option to use a different near surface wind, but if it's none, then it will just assume the wind field is constant across, like vertically. So for simplicity, we will not use those functions. But one more thing to be specified that you have to specify is this unique layer identifier. So here we choose to calculate the gradient, which is an essential part to calculate the emissions per orbit. You can also do that per day, which I think may not be slightly more inaccurate, or it could be fine, but usually I just do that per orbit. In other words, we calculate the emission for every orbit of Tropomi. And since we already have the necessary wind fields, we are not going to use this interpolate meteorology function. And for this calculate gradient function, it's also okay to just leave it as default. And finally, let's specify the flux grid size. So usually it should be similar to the level 2 pixel size or larger. So let's do that. So let's choose 0.06 degree. Let's see if it works. So it will take a short while. And once this level 3 object is generated, we can plot it and it will show the level 3, the column amount by default. Okay, it's done. So let's just plot the column amount. Yeah, so these are the tropospheric vertical column density of NO2 on that day, the first day of September 2021. And then you can specify to plot field, which is called wind column. That will give a first order estimation of emissions. It does not look very impressive for just one day, as it will take more average to get a meaningful emission field. So we can do that by averaging 1 month, for example. But it will take a few minutes. So instead, I will just, I have already done that, and I will load the pre-saved. It's exactly the same piece of code, but it's just spanning 1 month instead of 1 day. So let's read the previously saved NetCDF. Okay, it should be the right file. And we can specify which fields to load. Column amount and the wind column, which is the estimation of emissions. Okay, so those are the level 3 data for the month of September, and on the top, that's the column amount, and the bottom, that's our very quick estimation of emissions. So it's kind of a quick and very quick way to do that. And now it's still on NO2, so we need to kind of translate that to NOx, NO2 plus NO. Let's just make a very simple assumption that the ratio between NOx and NO2 is 1.32. So this will make the estimation slightly more realistic. Okay, that's pretty much our demonstration today. Feel free to explore over different regions and different times. And really, the only data that you will need are those level 2 files.